First type is fixed type, the permanent IC, neither fixed, neither permanent. So suppose we have two links like this and we have a terminal. This one is link 1 and this one is link 2. So this intersection of the 2 points right now is called as I12 and this is example of fixed IC. Wherever the link 1 and 2 go, the point of intersection will be either always represents your IC. So for permanent IC, suppose your link is like this and one of the link is grounded. So will this position of the link will change or will not change? But is the position of this IC will change? The position will change but is always between 1 and 2. And here suppose this is link 1 and this one is link 2. So will the link IC 1, 2 will change its position or it's always permanent? It's always permanent. So we have either permanent or either fixed. And third type is neither fixed, neither permanent. So this time we have 4-bar mechanism. This one is permanent. This one is permanent. Is it a fix? Is it a fix? IC can be obtained by extending the IC of this, and this one can be obtained like this. So this one is IC. This IC is 2,4 IC. In between 2 and 4 we have a link 3. So can we model this link 3 is oscillating about this point as a pure rotational motion. Now as the crank, this crank will change the position, will this mechanism will change the position. So is this point is fixed or is it continuously moving? It's continuously moving because your 2, 3 will move as well as 3, 4 will move, and therefore is this point is fixed or is continuously moving. That is why it is called as neither fixed nor permanent. We are going to locate all 6 IC. For this one you have to draw one circle, and how many number of points there, you mark them in numbers 1, 2, 3 and 4. Now just by observation, can you locate some of the ICs on this one? So some IC is what? This IC is 1, 2. Is this IC is 1, 4? Is this IC is 3, 4? So how many IC are known to us? One IC is 1, 2. One IC is 3, 4. One IC is 1, 4. And one IC is, how many IC are not known? 1, 3 is not known and 2, 4 is not known. So how you go for this? For this one, you want 1, 3. So 1 is here and 3 is here. So you have to draw this line. Now can you approach this line by first going by this way and then go by this way? So you can write like this. I can approach to 1, 3. So what I do? First I have to go for 1, 2 and then I go for 2, 3. At the same point, can we approach in the other direction also? So this time we are going for 1, 4. So second approach is 1, 4 and 3, 4. Join them and draw a line passing through them. Then second time, what you do? You identify I14 and I34. Where is I14? So I14 is here and I34 is here. Now you can locate them and draw one more line. If you do this, you will get another line like this. Now where these two lines intersect is that point your I13. Now what is left is I24. Now your next job is to locate I24. Now where is I24? I24 I have to go this way. If I want to go for this one way is this way and second one is this one. So let me write the path first. I24. So where I going first? 1, 2 and 1, 4. So you take one line from 1, 2 and 1, 4. Can you approach this point from another path also? That is, this time is this one and this one. So this time you take 2, 3, 3, 4. Now I12, I14, I12, I14. Join these 2 points and draw one imaginary line. Next 2, 3, 2, 4, 2, 3, 2, 4. So 2, 3, 2, 4. Is it like this? So where they intersect is this point is your I24. So this point is, so suppose we have a ball here and is rolling. So at this point, let's say this is a pure rolling motion. The rolling motion is a combination of translational plus rotation. So whether your ball is here or your ball will go to this point, the velocity at this point is always 0. Always 0. Where it will go to this one, the velocity is always 0 because it's a combination of what? Translational plus rotational. So is this point is always C. So for rolling, it's a IC. Anywhere you want find out velocity, what you do? You join this point with this one and just draw the perpendicular to this one in the same sense that of what? Omega. If you want to find out the velocity at this point, so join this point with IC and then draw perpendicular in the same direction that of rotation. So if the linear velocity of all these points are different, except at IC, velocity will be equal to 0. That where it may be, IC is always fixed, that is at this point. Okay, we have a slider here, and is this slider is, let's assume the slider is moving this way. Can we model this straight line in the segment of a circle having infinite radius? We can model this one. So where the IC will lie? So IC will lie somewhere at infinity. So what is the angular velocity of this one? 0. Angular velocity equal to 0, so angular velocity equal to V by R, and R is infinity. So what is 1 by infinity? It will lie at infinity. So suppose this one is link 1 and this one is link 2. So is it I12 location? That is at infinity. This one is I12 location at infinity. So, but if this straight line path I will show the curved path, and the slider is allowed to rotate inside this one. So slider will slide along this one. So is the velocity right now? When the slider will come to this point, will the velocity will be like this. When the slider will come to this point, will the velocity will be like this. And if you draw all the perpendicular to this one, will this perpendicular will intersect at a point. So this time, are we able to locate IC? And is this IC at a fixed distance? So for slider, if the constraint is a circular path, we can locate IC and is at fixed distance. But it is on the straight line, it will lie at infinity. 3 ICs and lie on straight line. Just come to this one. So are these 3 IC are on the same line? Are they on the same line? So this is what the proof given by Kennedy theorem. But it must have relative motion. Then only you can apply Kennedy.